Hey guys. Hi guys.
Hi.
How are you? Ashwat, nice to see you. So you have something else at 5:15?
Yeah.
Good to know. Okay. Hi Lasya, how are you, ma?
I'm good, Miss Priya.
Yes. Okay, what are they doing in school, ma? What are you doing in
We
school?
started linear regression.
You started linear regression. Okay. Thing is, we didn't do finish system of equations, right? We didn't finish the system of equations, right?
Yeah, I think.
Yeah,
Oh, yeah, Miss Priya. I did
Yep.
the homework, but I just didn't send it. Can I send it after class?
Absolutely, please. I would love to
Okay.
see.
Okay.
So let me go ahead. Try to solve system of equations using word problems, as well as let me do the elimination substitution method. Only graphing we did last week, right? Uh, Ashwat, do you know how to do by substitution system of equation solving? Not really. You don't know?
No, I don't think so.
Okay, let's see. Then I'll go to this 8.1 trend lines. Okay, let's see. We've gone to linear regression, but we have not done. But I don't mind finishing that and coming back. Last year for you as well, they have started system of equations. You're saying, right?
No.
The scatter, meaning plots trend lines, right?
Yeah.
Okay, so maybe we'll go over that and then come back to system of equations. Have they covered system of equations, ma?
No.
No. Okay. So then let's see. How about this? In a graph, right, you have x-axis, y-axis, correct? They are two different quantities. Any two quantities can be mapped, right? Suppose if x increases, okay, y increases. That means x is 1, y is 1. X increases in value, y also increases in value. If this is the case, how will the plot look like here?
It'll go up. It's positive.
Yep, it'll go up like this, right? In this scenario, we call this that the two quantities have positive correlation. Make sense? Can I move on? Suppose we have a scenario where x, y. X keeps on increasing 1, 2, 3. Whereas y, let's say tub of water is leaking. What happens? Tub of water was 10, 9, 8. What happens here? What type of correlation is this?
Negative.
Negative correlation. So how will the graph be? 10 comma 1, 9 comma 2. You see, this is negative correlation. Ashwat, are you with me?
Yeah.
Adyan, are you with me? Suppose I
Yeah.
have points like this, the last graph. Suppose I have points like x and y are there, but sometimes 1 comma 5 is a point, sometimes 9 comma 0 is a point, sometimes 9 comma 1 is a point, like this. What is this correlation? No correlation. Correlation means relation. Got it, guys? So there are three different ways. One is positive correlation, negative correlation, and no correlation. Make sense? Can I move on?
Yeah.
Okay. Now, how is this relationship measured? How is this correlation measured? There's something called, you should be able to quantify this correlation, right? Meaning how much of an attachment between x and y is there? How much they are related? You should be able to say that, right? So that quantity that quantifies the correlation between the quantities, right? X and y quantities is called correlation coefficient. Make sense, guys? This correlation coefficient's value can range from -1 to 1. Make sense what I'm saying? This correlation coefficient's value can range from -1 to 1. From 0 to 1, if it is there, I can call it positive correlation. In this scenario, I will get a value in this. In this scenario, my value will be here. Make sense, guys? In this, whatever this we are discussing, right? This is the strongest correlation negative. This is the strongest positive correlation. Did you get it? Make sense? Okay. This is ideal world data. Ideal world data will form a perfect straight line. You got it? Ideal world data can form a perfect downward going line. However, in the practical world, some of the values may be outside as well, not on that line, right? Meaning, let's say I discuss two quantities, okay? 2 cups, let's say I'm baking cups of sugar, cups of flour. Practically I did, okay. I used 1 cup of sugar for recipe, I used 1 cup of flour. Next is, meaning same thing I made it another day I used 2 cups. But when I practically make it one day I use 2.5 and a 3. So like that when I plot right, while most of the points will be on the line, let's say 3 comma 3, 4 comma 4, I plotted. But whereas this 2.5 comma 3 is as well here, right? So now, but I want to draw a line that connects the most points. So this is my line, right? This connects most points. This line that connects most points is called the trend line. Okay, the ones that there are some points up, I'm not bothered about it. Okay, they don't make a big difference. 1 second, guys. Did you get it? Did you get it? Trend line, positive correlation, negative correlation, correlation coefficient. Make sense? Now, let's say I am going to plot latitude numbers on my x-axis, okay, and average annual temperature on the y-axis, okay. I am getting points like this. What type of correlation is this? What type of correlation is between average temperature and latitude? When latitude increases, what happens to average temperature?
It decreases?
It decreases, yes, because latitude goes on increasing, average temperature goes on decreasing. See, this is my trend line, right? And how is the correlation, positive or negative? Both increase, both decrease, then that is positive correlation. One increases, one decreases is what type of correlation? Negative correlation. And the value can be between 0 and -1. Make sense, guys? When most of the points are on the line, then it will be towards -1, like a -0.99 or -0.98 or -0.9. It will be like this when most of the points fall on the line, trend line. Make sense?
Yeah.
Okay. So this is just the theory part, but practically you have to experience this. Suppose if there are two quantities and if my correlation coefficient, let's say this is 0, this is 0.5, this is -0.5. The correlation coefficient is defined by R. Correlation coefficient is defined by R. Okay. This correlation coefficient, suppose in some x and y values, right, I get a correlation coefficient of 0.4. What can I say about it? If it is 0.4, where does it fall? It falls somewhere here, right? What can I say about this correlation coefficient? Is it positive, negative, or what?
It's positive.
Positive. Is it weak positive or strong positive?
Weak.
Weak positive. That's how you categorize correlation coefficient. Suppose let's say I have a 0.8. What can I say about it?
That would be near the strong positive, right?
Yeah. Ashwath, this class is so much better, right, Ashwath?
Yeah.
I know, that's why I've been asking you to come for this. Okay. Now, suppose let's say my correlation coefficient is minus 0.3. Adyan, do you want to say what sort of correlation coefficient is that?
Is it strong? No, weak positive? No, or strong?
You tell
Yeah,
me.
weak positive.
Weak positive. Last year you know now, right? 0.7. How about that? Minus 0.7, sorry, ma.
It's mild.
What, ma?
It's negative, but it's like mild.
Mild, illy. See if it is towards, this is your strongest. So it is strong negative. Make sense?
Here's Priya.
Yeah, ma?
Wouldn't it be weak negative for negative 0.3?
Oh, yeah. Sorry. It was my bad. Thank you for the catch.
Yeah.
Make sense?
Mm-hmm.
Lasya, did I make it clear for you that is strong negative?
Yeah.
Anything around 0 is weak. Got it? Okay. We are good there. Now, if I give you a table, right, how will you fit these functions? If I give you a table, how are we going to fit these functions? Let's see. You know how to type in to the calculator, guys?
Yeah,
Do you know how to type it into the calculator? Do you know how to type it into the calculator?
I do, Miss Priya.
Okay, so when you're given a table of data, you should be able to give the equation of best fit. You should be able to give the equation of best fit. Okay. Let's say how to find that equation of best fit. Let me show you a table. Okay, meaning from a table we can always plot a graph, right? Years. Suppose I'm planting a plant. Okay, I'm measuring the number of years it grew and the height. Okay, starting when I planted it, it was 2.1 feet. Okay, in the first year it grew to 4.3 feet. The second year it grew to 5. In the third year it grew to 7.3. Fourth year 8.1. Fifth year it grew to 10.2. Okay, this is the growth of the plant within years. In this scenario, meaning this is basically a linear one. Okay, linear meaning linearly it grows up, meaning as the years go by, see, x-axis increases, y-axis also goes on increasing. So basically I can plot it into a coordinate plane, correct? When I plot it to a coordinate plane, it's not going to be a straight line. Okay, so when you look at it, right, let me correctly plot and show you. 0, 2.1, 0, 2.1, 1, 4.3, 2, 5, 3, 7.3, 4, 8.1. You see guys, it's not a straight line, you see? So I can choose 2 points. Let's say I'll choose 2 points. Meaning, see, when I want to draw a trend line, I have to choose 2 points. Let me choose this and this. Okay. When I choose those 2 points, this is what will happen, right? Meaning you have to use a scale and draw. You have to connect those 2 points. Yes, one of the points did not fall on the line. That's okay. Doesn't matter. So the chosen points are 0, 2, 5, 10.2. Now, what is the slow? See, if I want to find out this line equation, I want to know this line equation. That is a line or trend line, right? Or I can call it as line of best fit. Line of best fit or trend line. How to write the equation of that line? Can you all tell me how to find the equation of that line? How do I find the equation of that line? You guys know. How do I do it? Any line equation is given by y equal to mx plus b. How to find out m? How to find out b?
B is 2.1.
Yep, B is exactly 2.1, right? Yeah, and then
M is
M is what?
2.
Can I choose these 2 points? 10.1, 10.2 minus 2.1 divide by 5 minus 0. Can I do that? 8.1 by 5. Can I do that?
Yeah.
1.62, correct? So 1.62x plus 2.1. Make sense? This is the equation of my trend line, or this is the equation of best fit. Make sense?
Yes.
Can I move on?
Yeah.
Okay. So you understand the relation, right? Meaning if you want to find the equation, trend line equation, this is how you do that. Make sense? Okay, now let's go ahead and try to find the equation, the trend line equation. We'll also start finding the correlation coefficient. Shall we try finding what is the correlation coefficient? Let's see. Really want you to be able to fit that to a correlation coefficient. 1 second, guys. You should be able to find out the correlation coefficient. Okay, let's first try to find out the line of best fit. Okay, let's see this one. How about this? I'll give you a data. You are going to type it into the calculator. If you don't know, I'll help you. So, number of hours I studied for a test. Okay, score I got. I'm plotting, those are the two values I'm giving, meaning two different XY values I'm giving. Okay. Practical value. So it may not form a straight line. But then you can find the equation of the line of best fit. You want to find the equation of the best line of best fit? Go ahead. Go ahead. Find the slope. Find the intercept. Write the equation of line of best fit. First, plot the point. Then tell me what is the equation for the line of best fit. You can use a graph paper, or you can use, meaning, yeah, I can see whether I can do it for you. Want me to find it for you? I can find it. Hold on. You're able to see my board, right, guys? Are you able to see my board?
Yeah.
Okay, okay. Okay, go ahead. Try to find the equation of best fit, guys. Draw it in, I can see whether I can do it in a graph. Wait, let me see. Let me do. Mm. I don't know where I can do this line of best fit online. Let me see. I'll do it, guys. Wait. Graph pad is good. Line of okay, GeoGebra or Desmos is good. Okay, I'll do it in Desmos. So let me draw. Let me do the table, guys, and then I'll share my screen. You can as well do it. Do you know Desmos calculator, all of you? 263, 271. Do you know Desmos calculator?
Yeah, you showed us last week.
Oh yeah. Same thing, continuation.
Uh,
Ashwath and last year, do you know, guys? 63, 71.
No.
Okay, I'll help you. Go to Desmos graphing calculator. Go to Google, go to Desmos graphing calculator. You have to do it in parallel with me. One second, guys. Let me check how to find the line of best fit. Desmos. Hmm.
After I get there, what do I do?
Then in the new expression. Oh, see. One second, Amma. I'll help you. Then in the new expression and type. See. Okay. This is what you do. Let me share my screen so you should as well see what I'm doing. Chrome, Desmos, line of best fit. Are you all able to see my Desmos calculator? You're able to see, right?
Yes.
Okay.
I'm on that one as well.
Okay, good.
I don't know how to use it though.
Yeah, but see, when you click on the plus, then there is a table coming up, right?
Okay.
You can type in the tables.
Uh-huh.
Make sense?
Yeah.
I don't want, see. Now if I want, okay, I just type it out in the table and then I can add, see there is this dot 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 coming, add regression means, if I add regression means it will plot a line that goes through most of the points, which is the line of best fit, and the equation it will give, equation of that line it will give by itself. You don't have to compute basically. You got it? Did you get it, Ma? But you have to know you have to do this in a graphing calculator, guys. Do you know how to do it in ticalc.com? ti84calc.com. That's where I want you to do, because I want you all to buy this calculator. Hey, Ashwath, do you have a calculator?
No.
Did your sister not get one?
Think she did.
Okay, so you have to start using that. For that, you go to stat. You have to go to stat, edit, type in the values. What are the values? 2, 2, 2.53. Last week I told you, right? 2, 2, 2, 2 to 2.5, right? Then 3 and then 4.55. 4.55. And after that, go to the other side, type 63, 71, 75. 63, 71, 75. And then what did I give you? 67, 82. This is what you have to know. For sure, you have to know this. 95. Then go to graph. Nothing is coming. I don't know what. Wait, start.
Yeah, if you click stat, go side to calculator, like calc, down to linear, not for linear regression.
L1 correct, L2
No,
correct, X
calculate.
correct, right? Na?
Calculate and it gives you like the values.
So see here, you can model this line as what? Good ma. Model this line as 50.42 plus 7.92x. That is the equation of this line. Make sense? But you know what I told you about regression coefficient, right? It's not appearing here. It should appear here. You know what?
That you went down
Uh-huh.
to like 8. It's number 4 instead of number 8. I don't know, but
Wait. Let me go back. Yeah. I hear you, but I think it's the same. Let's see.
no, they're both different because I got the R value. That one, no, up 4. That
Okay.
one, and then go
Yeah,
down.
let me show you. I won't get the R value. I'll tell you why. See?
Oh,
You know, this was the same question that came up in the other class. Huh?
your diagnostics on.
Yes. So, see that correlation coefficient is not there, right? So, we need to understand what is the relationship between the x and y, right? How much correlation, how much they're associated, we need to know, right? That's quantified by the correlation coefficient, right? How to find that? So, go to mode, make sure when you click on the mode button, see diagnostics. Where is the diagnostics? See, start diagnostics off is there. Make it on. Then you go back. You put it on and then you go back. Okay, that's done. Now go back. Where did you go back? Start. Start, calc, linear regression. Okay, now come calculate, enter. See, R value is 0.88. So what is the relation for this X set of values and Y set of values? What is the correlation? Is this strong correlation, weak correlation, strong positive, strong negative, weak positive, weak negative? What is it?
Strong positive.
Yeah, strong positive correlation. You say X and Y are strong, have strong positive correlation. Adyan, are you understanding?
Yeah.
So this is how you find the correlation coefficient. Got it, guys?
Miss Priya, on the Desmos one, it says like R equals 0.8707.
Did we type in 263 is that right? Yeah, 71, 75, 67, 82, 95, 2.53, 4.55. Yeah, it does say that 7.9 to 50.2. 50.2 2.42 correct. R ma, don't see R square.
Yeah,
R,
R.
you got it?
Yeah, R. It says
Ah.
0.8707.
8. But then you did type something wrongly. Did you see 263, 271? Did you type it correct?
Oh, I thought it was 62.
That's the deal.
Okay.
So don't see R square. R is the correlation coefficient.
Okay. It says 0.8823.
Yeah, correct. Got
Okay.
it?
Yeah.
Can I move on? So correlation coefficient. Did you discuss residuals as well in class last year for you?
What is Priya?
Did you discuss residuals?
No.
I really don't want to discuss that, but you know how to do linear regression now, right? You know how to see whatever line you get out of linear regression is the trend line or the line of best fit.
Miss
Um,
Priya, can I go get water?
yeah, you can.
Okay,
Suppose
thank
let's, yeah, ma, go. One thing what I want you to understand, this is the line that connects most of the point, right? But when you look at this point, that point is slightly higher than the actual line value, right? Actual line value is here, right? For that point, actual line value is where? For that point, actual line value is here. So this distance, right, it's a positive residual. For this point, right, when you think about it, the actual value is on that line. So this is your negative residual. Am I making sense?
do you know if it's positive?
What does that mean? If it is above the line, it's positive residual. If it's below the line, it's negative residual. Residual means residue left out.
Okay.
You got it? So, if any point is above the line means this is your positive residual. If the point is below the line, this is your negative residual. Make sense? Does that make sense?
Yeah.
You can square the residual. Whatever be the residual value, 0.2 or point, this is minus 0.2, this is plus 0.2, like that, right? Don't worry about your residual, but just you need to understand the concept of what is residual. You got it? Residual means whatever is not fitting in the trend line, right? The points, the distance from the actual point to the trend line. It can be positive or negative. The left out piece is called residual. Ashwath, are you getting it, Ashwath?
Yeah.
Think, can I move on?
Mm-hmm.
Okay, now you know how to find linear regression. So the residual, a linear regression, okay, line of best fit, you know, whatever results, the line that results from a regression is the line of best fit. But you know what? I have not discussed the sum, the squaring residuals and stuff. Should I discuss that? I don't know. Mm, 1 second, guys. Mm. Okay. So now, guys, you know what is the residual, correct? Suppose, let's say you want to really understand what is the residual. Let me see. Okay. How about this? Okay. Now, I am calculating, let's say, let me consider another scenario. I'm calculating the median age of females from the year 1970, 1970, 1980, 1990, 2000, 2010. Okay. All these years I'm calculating the median age of females. Whenever I have years, right, I have to start with 0 for the first year. Always I'll have to rewrite the table. Please remember that whenever in mathematics you have years, right, you always rewrite it from 0, 10, 20. The distance from here, 30, 40. Like that I rewrite the tables, okay. The median age has been calculated as 29.2, 31.3, then 34.0, 36.5, and then 38.2. Any question till here? I gave you the tables here. There's nothing for you to do, right? 31.3, 34, 36.5, 38.2. So this is your X value, this is your Y value. Any questions still here? Any questions still here? Now, what is the line of best fit for this one? What is the equation of the line of best fit? Who's going to tell me? This is the actual values that you got. Okay, practically I performed experiment. Okay, in 1970, practically it was determined that the median age was 29.2. This is not going to get you a straight line. Can you tell me the equation of best fit? If you can tell me the equation of best fit, I will write it down here and calculate how they are differing. I'm going to see. Can you give me? Are you getting the equation of best fit, guys?
I sent you my answers.
You can tell me. Shout out, ma. I'll just write down. I'm going to show you something. Go ahead and show.
X equal to 0.23x plus 0.99.
Did you both get Adyan and Ashwath? Did you get it?
Yeah.
Amma, is that right? 0.23x plus what, ma? 0.99. Is that right, Lasya?
Pretty sure I put my numbers in.
Because you see the x-intercept is 29.2. How you will get that? Then the intercept should have been 20. I want to calculate it, guys. I'm not 0, 10, 20, 30, 40. I'm going to erase these off.
Oh wait, my bad. I read the y-intercept is the r value. The actual answer is 29.2 for y-intercept.
That's what I thought, right?
The r
So-
value is 0.9.
Okay, let me change. 29.2, 31.3, and then what do I have? 34, 36.5, 38.2, right? Here, this is what I have. Regression. Yeah, ma.
Y-intercept.
What was that? 20? 2, 3x and 20. This is 29.2, right? Yeah. So, guys, you're getting an equation. This was your actual, right? Substitute 0 in there, you get 29.2, correct? Now, you substitute 10 in there, what happens? If you substitute 10 in there, if you substitute 10, right, what would you get there? 2.3 plus 29.2, right? 31.5, correct, guys? Substitute 20 in there. If you substitute 20 in there, what happens? 4.6 plus 29.2, right? 33.8. Am I making sense, guys?
Yes.
Adyan, did you understand what I'm doing?
Yeah.
But you have to be on the video. 0.69 plus 29.2. So this was 6.9. Yeah, 6.9. Next value. 36.1. So you get some values, right? What is this? What is this? This is based on your equation of best fit. You are plugging in values. So these are the predicted values based on equation. Make sense, guys? So what is the residue? What is the residue here? If I plot these points, actually I have to plot 0, 29.2, 10, 31.3. But based on the equation of best fit, when I draw the line, the line's equation will tell me for 0 it's 29.2, 10 it is 31.5. So what is the difference between these two? What is the difference between these two called? What is the difference between these two called? I told you just now. What is the difference between the predicted and the actual? Residue. 0. This one is what? You should always subtract actual minus predicted. So minus 0.2. This one is plus 0.2. Then this one you have to calculate. You got it, huh? This one we already calculated, right? Actual minus predicted, right? So that would be actual minus predicted is 0.4 plus 0.4. Make sense, guys? Some residuals will be positive, some residuals will be negative, correct? But then one thing, see, you can as well plot these residues into a graph. Take this as 0. Minus 0.2 will be here, plus 0.2 will be here, 0.4 will be here, 0 will be here. If I plot these residues taking this line as 0, okay, this line as, this is plus 0.2, this is minus 0.2. If I take it like that, I plot these residues into a graph. Do you see how I am plotting these residuals into a graph? When I plot it, see, One is at 0, one is at plus 0.2 minus 0.2, this is plus 0.4. Like that I can plot the residues into a graph by themselves. However, see, when the residual, all the residues get cancelled, then only your graph is perfectly right, meaning the residues should basically be 0. You want a perfect line means, right? This positive gets cancelled with this negative. So rather than having positive negative values, you can square the residuals. Residual square you can do. You can square the residuals and make everything positive. You see? Do you get it, guys? Now, when you square the residual, you can sum up all the square of the residuals. Got it? Whenever you sum up all your residual square, right, when that value is minimum, then the graph is perfect. Meaning, when the squares of the residual is smaller, right, then the line of best fit perfectly matches all the lines. The squares, because the residual is the error, right? Basically, the error should be minimum. So when you square your errors and add them together, the error is going to be reduced because always the decimal values you're going to multiply, right? When you multiply a decimal by the decimal, this error is going to reduce, but then everything becomes positive. So when you sum up the squares of the residual, the lower the value, the better line you have got for the best fit. Makes sense, huh? Am I making sense? Maybe the school is not going to discuss this, but it's quite important to understand how this all works. Make sense? Make sense, guys? Any questions here? No questions? You got how to find the residue, how to square the residue.
Yeah.
Residue means the difference between actual minus predicted. Actual is whatever is given in the table. Predicted means based on the equation that you are getting, right? You are going to find the values for the predicted. The
Yeah.
difference between actual minus predicted is your residual. Residual square you can do, but if you sum up the residual square, the lower the number, the better is the line of best fit. Lasya, am I
Mhm.
with you? Am I with you, ma? Okay. So you know how to find the correlation coefficient. See, finding the correlation coefficient is a sure shot, usually a sure shot question in your end of course exam. End of course exam definitely has um, one question on finding correlation coefficient. Now, I'm going to give you a graph. You're going to find the correlation coefficient alone. Okay. 1, 2, 3, 4, 5, 6. This is the graph. You're going to find the correlation coefficient alone. 6.3, 2.8, 8.73, 5.9, 1.2. Honestly, I want all of you to start using TA84 calc only. Don't use Desmos. Because SAT exam, it's better to use the same calculator. Let me know if you, my share, what am I doing? Go ahead. Oh, you're not able to see my screen, huh? Desmo screen. Are you able to see my Desmo screen or not?
Yeah, we can see it.
Go ahead. So you're going to put it out into the, don't use Desmos, guys. Use TI calc and find out the regression coefficient for this set of data. I want to know whether it is positive correlation, negative correlation, strong positive, strong negative. What do you think? If we do that, that's an achievement today. Mm-hmm.
Miss Priya, it says that you paused a screen sharing.
Oh, it is paused. Sure. Now, how about now? Are you
Oh,
able to
yeah.
note down the answers, ma? Hey, I just want the correlation coefficient last year. Is it so, Lasya?
You got negative 0.609.
Yeah, I'm seeing your value, but what is the value, Adyan?
Oh, never mind.
Send the value, right? How do I know the value? I'm at a loss. That seems a little different, but I don't know, Lasya. Maybe the book is wrong. And sometimes the keys are incorrect, so it's okay. Let's see.
But Miss Priya, can you help me on it?
So I'm plotting for you. I'm putting out the table values, right? You want
Okay.
me to do it in Desmos? You wanted me to do it in TI-84 Calc? Wherever you want, I'll do and show you.
If you round the R value up, you get negative 0.61 then.
Yeah. Did I give it to you correctly? 9.6, 6.3, 2.8, 8.73, 5.9, 1.2. Interesting. Okay. Last year, I think you got it. That's fine. Ashwath, did you get it? Did you get it? Adyan, what calculator are you using?
Decimals.
Desmos. You should practice only in TI-84.
Okay.
That will only help you for SAT exam.
Okay. My school also wanted me to buy a TI-84, but we didn't get it yet.
Yeah, I told you, right? It's so important to buy a calculator. I'm going to message the parents now.
Okay.
Can I use Desmos right now since I don't have the TI-84?
Yeah, you can, Amma. It's somehow you, yeah.
Okay. Do I send you the equation?
Yes, send the equation. Also send the correlation coefficient. Hey, Adyan, did you get it how to do? I typed in the values. Are you able to type it and click on the regression? You have
Uh,
the, yeah. So I
for
want you,
some reason, it's only showing me the two slots.
what two slots?
It's only giving me like for X1, it's only giving me the only two plots only. Like,
To share and show me, otherwise it's very hard.
okay.
Honestly, I don't understand what you're saying.
So it's just letting me do these two, and then I can't do. Oh, and then I can't do anything other than that.
You want
Wait,
to
can I?
show?
Oh, my bad. Sorry. I.
Lasya, you got it nicely, right, Lasya? Got it, ma? Adin, are you going to share? We are waiting.
Well, I think. What did I not share?
No.
Oh, I was. I found out what it was now.
You want to show us? Or what
No,
do you?
I already got found out. I messed up.
Okay.
I
So, Ashwath, that's correct. So, it is strong negative correlation. Did you guys understand that?
Yeah.
Okay, now I'm going to go ahead and show you how to plot, how to solve linear systems using substitution. Graphing we discussed last week. Remember, if you're given two linear equation, how to find the point of intersection is something you need to understand. If I give you two linear equations, you should know how to find the line of intersection. How about this? Suppose if I give you, see, I will do it for you. Two linear equations I'm going to give you. Adyan, did you get the value? It should be 0.6 minus 0.6.
Yeah.
If I give you two linear equations, how will you solve the intersection algebraically? Last week you typed it into the calculator, you found the intersection points, right? But that's not what I want. I want to go ahead and find, let's see, let me use this equation. Can I find out what is x? Plus 3y on both sides. If I add 3y on both sides, I know what is x now. 9 plus 3y. So wherever I see x, right, instead of x, in the next equation I come, wherever I see x, I'll substitute with 9 plus 3y. Make sense, guys? If I do this, see what happens. 9 plus 7y equal to 2. 7y equal to minus 7. Subtract 9, subtract 9. Y will be equal to minus 1. Now I go ahead and substitute this. Y equal to minus 1 means x will be equal to 9 minus 3, 6. Make sense? Does it make sense, guys, to all of you? From one equation, I find x or y. Substitute that in the next equation. Make sense? You get one variable. That you substitute into our equation and find out the other variable. Make sense? Okay, let's try this one. X plus y will be equal to 4 minus x minus y will be equal to 6. Want to try that? X plus y equal to 4 minus x minus y will be equal to 6. Can you do it by yourself or do you want me to help? Guys, you need to tell me. Let me know if you need help, guys.
It's Priya. Can you do it on the board?
Huh?
Can you do it on the board?
Yes, I can. Thanks. Ask, Ma. If you ask, I'm so happy rather than you keeping quiet. So, I'll use the first equation. Okay, I'll use the first equation. Find out one variable. What do you want to do? Meaning, can we find out what is x? Then subtract the y from there. I want to retain only the x, right? So, minus y plus y will go off. So, x will be equal to 4 minus y. Am I making sense?
Yeah.
Now I plug that into this. How to plug it in? Instead of the x, there is a minus, please copy that. But instead of the x, I can copy 4 minus y. Please put it in brackets. Minus y will be equal to 6. Make sense, guys? Last year, are you with me? Now, distribute the minus. Minus 4 plus y minus y. Oh my goodness. Okay, good. We are good. So, minus 4 equal to 6. What are we arriving at? We are arriving at a very false statement in mathematics. That means the two lines do not intersect. Two lines do not intersect. There is no solution. If there is no solution, how are the two lines? The two lines never intersect. Then what are the two lines then? When you plot the two lines, how the two lines will be? They don't intersect at all. How will the lines be? You tell me.
Will they be parallel?
They are parallel. Good job. Very nice. That is when you get such weird answers. You get a false statement. Sometimes you may end up with phi equal to phi. This is a true statement, right? In that case, both the lines are the same. They both intersect all the time. So you have infinitely many points that are intersecting. So you have infinite solutions. Make sense?
For that, shouldn't there be a variable?
What is that?
Shouldn't there be like 5y equals 5?
Yeah, you can, it's the 5y equal to 5y that you accept, right? So this is a true statement. Yes, you can arrive at this or 10 equal to 10 or minus 5 equal to minus 5 or 5x equal to 5. You can arrive at anything which is true. Then in that case, it has infinitely many solutions. That means both the lines are one and the same. Usually when there are two lines, for the two lines to have one solution, they intersect at one point. That is the usual thing. But
Wait,
there
Miss
are,
Priya,
yeah.
wasn't this on the homework?
Yes, because of graphing. Using graphing you did. Now
Uh-huh.
you're using substitution. I'll solve one more and show you. What I'm
Okay.
saying is, see here, x minus 3y equal to 6. 4x minus 12y equal to 24. What can I do from the first equation? Who's going to help me?
So we have to bring 3y by itself, so we have to put the yeah, we have to do that. So then it would be minus no, I meant x. Wait, is that x? Yeah, x equal to.
Oh, sorry. My x's are so different, right? I don't know how to change myself.
It kind of looks no. Okay, so basically it
X will
would
equal
be
to what?
x would equal to uh 6 plus 3y.
Okay. Now what do I do?
Uh, we have to subtract wait. Oh yeah, we have to substitute the 4
Instead
like
of
that.
x, I'll substitute 6 plus 3y. Put it in
Yeah.
brackets. We'll see later. 12y equal to 24. What do I do now?
Yeah, substitute that. So it would be 24 plus 12y minus 12y equal to 24.
What happens now?
Uh,
What do I get?
yeah, you cross out those two. So it would be 24 equal to 24.
What does it mean? I
Uh,
arrive at a true statement, right? I don't
yeah,
get the value, but I arrive at a true statement. That means what? Both the lines are
crossing each other.
one and the same.
Yeah, one and the same.
One and the same means this is the same line as this. In that case,
Mhm.
what would happen? There are infinitely many solutions.
Yeah.
That's what it is. Make sense? Lasya, are you with me, ma? Very clear? Okay. Ashwath, you go ahead. You have to go, I think, right?
Yeah.
Bye,
Bye.
bye, Ashwath. Yeah. Bye,
Thank
Ashwath.
you.
Yeah, bye. Adyan, did you understand, Adyan? Lasya, did you understand? Can I give you homework on these two?
Yeah.
Okay, you have the book, Lasya, with you?
I do.
You have the book?
Mhm.
Okay, the thing is, by graphing we did last week, right? So for this week, I would like you to do 417 to 429. 417 to 429 and also 417 to 429. Along with that, 417 to 429. And then I would also like you to do correlation coefficient homework. Okay, I'll do 417 to 429. I don't know. Let me go ahead and give you some correlation coefficient homework, okay? Okay, positive correlation means one increases, the other increases, right? I'll just give you 417 to 429 in the book. For correlation, I'll give you a separate homework, guys, okay? Can I stop here? Can I stop here, ma? Can I stop here, Lasya? Okay.
Yeah.
Okay, see you all next week, guys.
Yeah, okay. Bye. Thank
Bye,
you.
guys.
Yeah.
Bye, guys.